Hi everyone, welcome back to CS128 Honors. Today I'm going to be going through Lecture 8, which is an introduction to structs. So what we'll cover today we'll cover structs in Rust, how to define them, how to instantiate them, and also some ownership problems related to structs. So for today's topic, the reading will be from the Rust book chapter 5.1 on defining and instantiating structs. So this lecture should be quite straightforward and simple, and let's go. So firstly, what are structs? Structs are short for structure, and they're basically a composite type in the sense that it's one type that holds together multiple related values. So they are similar concept to objects in OOP languages like Java. So you might think to yourself that actually we already have a type called we have tuples, right? And you can hold is one tuple and holding an object of different types. So actually the difference between a struct and a tuple is that in a struct you can name each piece of data, and this will be useful when you want to access the data compared to accessing it by indexing in a tuple. So we'll look at some examples. So defining a struct is really straightforward. We just use the struct keyword as we see here. So for example, here we define a struct that's called car, and basically each of these properties that you define in the struct are called fields. So in here we define three fields: the brand, the make, and the miles per gallon, which I shortened to MPG. And the syntax here is the name of the field that you define followed by the type. So this is brand, which is of type string, make, which is of type string, and then MPG, which is of type 32-bit signed integer. Now we're going to talk about how to create an instance of a struct, right? So this struct that we've created, struct car here is now like a type. So you can create like an object of type car, right? So down here, we'll give an example of an instantiation. So for example, we create this variable called my underscore car, and this is how we instantiate a struct. We have the type name, which is car, and then basically we define a specific value for every single field, right? So for brand, we use, since this is a string, we initiate the string from, for example, here I use Toyota, and make, we do string from Camry. So for brand and make, since they are type string, we need to do the string initialization. And for MPG, since it's an integer, we can just type the integer 30 here. So to instantiate the struct, we just specify a concrete value for each field. Next, another thing I want to bring up is that when we instantiate a struct, the ordering of the fields does not matter. So for example, here we define the struct car to be in the order brand, make, and MPG. So when we instantiate a struct, previously we also follow the ordering of brand, make, and MPG. However, actually you can reorder them. For example, you could use MPG, make, and brand. So here I switch the ordering around, but this is still a valid way to instantiate a struct. So the next thing that I want to talk about is the dot notation. So the dot notation can be seen here. For example, mycar.mpg and mycar.brand, mycar.make. So basically we use the dot notation to access the fields of the struct, right? So it can be used to just access the values for reading, and it also can be used to access the values to modify them. So for example here, I define the car again, called my car, and then for example here we let my car mpg equals to my car.mpg. So this is a example of a value access, accessing the field of a struct, right? And here for example I do my car.brand equals a string from Chevrolet. So this is example of accessing the field of a struct in order to modify that field. So here we're giving the brand field a new value, we're giving the make field a new value, and we're giving the mpg field a new value. So notice that when we want to edit the fields of this particular struct that we have instantiated, we need to declare it with the mute variable. Again, just to remind you, this is to ensure that the variable my car itself can be mutable and the values can be mutated. Next, I'm going to talk about the field init shorthand. So basically what this means is that for when it comes to structs that have a lot of fields, it might be tedious to have to keep typing the name of the field followed by a specific value, name of field followed by specific value. So for example, here we already have variables called brand, make, and mpg, which are already initialized. when we instantiate the struct like this, for example, let your car, we can actually just directly use the name, as long as the name is the same, the name of the variable is the same as the name of the field that is defined in the struct. We can use it directly, and we don't have to use the brand colon and then specific value notation. So this does not look like it has a extra like use here, but actually this is very useful, for example, when we have functions. So for example, when we pass in a string to a function, and in that function we instantiate an instance of a struct, we can directly use a variable like this. So one of the last things I will talk about is the struct update syntax. So this is the scenario when we have two different structs, as in, or we already have an existing struct, and we want to create a new instance of the struct using the values from the one that we already have, right? So for example here, earlier we defined the my car struct already with all the values already defined, and now I want to create a new struct called steal car, right, of type car, that I want to redefine the MPG to be 60, but for all the other values, I want it to be the same as my car, so I don't want to have to redefine it. So what can we do here? So we can use this struct update syntax, which is essentially as we've seen here. So first, we specify the fields that we want. So for example, if we want to specify the MPG, we can do 60. If we want to specify the brand, we can add another line, brand, and then we can do string from something. And the remaining fields that are not explicitly specified will be taken from the struct that is given. So in this case, we'll take it from my car. So one thing to take note when using this struct update syntax is that the ownership does change. So for example, again here, I bring up this example that we have in the previous slide. I redefined MPG, but for brand and make, I decide to use the value from my car instead. So what happens here is actually my car was defined like this earlier. Now the values of brand and make, which is like Toyota Camry, will be moved into this new struct called steal car, right? So now if we try to access the brand and make of my car, the compiler will actually give a compile time error and will not be able to use it. So it's very important to note that whenever we use this struct update syntax and we use a value from another struct, we are actually taking the value is moved from the previous struct to this current one. So this will be important, as not knowing this can actually cause you some bugs. So now we're going to go to a demo of this and see what actually happens. So here on the right side, on the left side here, I have the code, and on the right side here, I'm going to do the compilation, right? So here in the code, as we can see, we've defined the struct as we've said it in the slide. We have a brand, a make, an MPG of type string, and I32. We created a my car using this values. So now we are going to create our new car, right? So for example, just like in the slides, I created steal car, and I do MPG is 60, and I take the remaining values from my car, right? So this is the field update syntax. Now, for example, if I try to print my car.brand, as we've said earlier, what we expect here is that the brand, which is Toyota, is moved into steal car. So now if you try to access my car.brand, it should be invalid. So let's save this and let's try to compile it. So cargo build. So for example, you can see here that the compiler does give an error, so which is exactly like what we said, right? So when we define steal car using this struct update syntax, where we take the value from my car, the value is moved. And now if we try to use it here, the compiler will tell us that the value is borrowed here after move, which is invalid, right? So we can't actually use the value because it is now moved already, and now my car doesn't actually have ownership of the value, right? So for example, if here we use mycar.mpg, we see here that in the steal car we define its own mpg, so the mpg value is not moved, right? So actually mpg is a bad example because it's an I32. So let me try something else. So here, for example, let's say we decide to define the brand instead, right? So we define the brand, let's say we call it a Ford, right? So So now Steel car will define its own MPG and brand, and the value that it takes from my car is just the make, right? So now if we try to print my car.make, what we expect here is that the value is still moved, right? Because steel car takes the make from my car, right? So let's try it out. Right, so we can see that this is what we expect. Now if we try to take mycar.brand instead, right? So when we try to run mycar.brand, we notice that since steel car defined its own brand, the brand from my car is now moved into steel car. So this should be valid and we should be able to run it. So let's try it. As you can see, this built successfully. Now let's try to run the program. So now we can print out the brand, which is Toyota. So now because the value is not moved, this is valid. So that was the demo for the ownership changes. So the announcements, Homework 6 is released today on Prairie Learn and is due 1 week from now. And MB2 is released as well on Prairie Learn and is due 2 weeks from now. So take note of this. If you need any help, feel free to come to office hours. We have office hours every day. And have fun coding Rust.